Hello everyone. In this video we're going to see how we can use large language models like LLMs for text summarization. This project is on GitHub. You can try for yourself, just clone the repository and everything is going to run locally. Our goal is to take a GitHub issue like this one. This is the typical GitHub issue. You see comments being exchanged. We see the original issue being posted at the top. Our goal is to take this, which is usually verbose. People are giving details of the issue, what they're trying, what works, what doesn't work. We want to take that and create a summary out of it. And this is how the summary is going to look like. At the top we have a summary of the issue. And at the bottom we have a summary of the comments, like one line per comment. We're going to review the following topics as we do this work. Number one is how we prepare the data to use with LLM. We cannot simply use the data we get from GitHub to send to the LLM. We're going to see why. How to build the prompt. The prompt is one of the most important things here to instruct the large language model to do the work for us. In number three, we're going to see how good the large language models are at summarizing text or GitHub issues in particular. In number four, we're going to see some techniques to develop applications that use a large language model, including some other limitations. In number five, we're going to revisit the roles of prompts and how we can create some good prompts. And in number six, we're going to see when not to use large language models. The examples that we're going to see, they use OpenAI's GPT behind the scenes. These are the same models that are used by ChatGPT, but the techniques that we use here, they apply to any large language model. Before we go into the details, let's see an overview of what happens. So everything that we're going to see in this presentation is part of the GitHub repository, including this explanation. This is the README of the repository, so if you go to the repository, you're going to find all this information there. Let's start with the picture. Let's make it a bit bigger. This picture shows the major steps that we have to take to get the summary. The user is going to enter a URL. We take that URL and go to the GitHub API to get the issue and the comments back. Then we translate that into that JSON format that we get from GitHub into a compact text format. We're going to see why that's important. We build a prompt with instructions for the large language model. We send that to the large language model. We get a reply back, and that's what we show to the user at the end. So these are the major steps to get this done. Before we go now into the details, let's see how it looks like from the outside. That's the application. So you can paste a URL here, or we have some sample URLs here so you don't have to type. So let's pick this one here. And we're going to request a summary using GPT 3.5 Turbo. That's one of the GPT models. When we press the button here, those arrows that we just saw, they're happening behind the scenes. We're going to GitHub, fetching the issue. We're going to the large language model, asking for a summary. And here, starting here, is what we get back from the model. That's the summary. We can see at the top here a few more details. For example, from here we can see that we sent 1,300 tokens to the model. Tokens are roughly words. They're not exactly the same thing as a word, but you can think of them roughly as words. So we sent about 1,300 words to the model, and we got back 303. We got a lot fewer because that's exactly what we want. We want a summary. So we expect to get a lot fewer tokens back. In this particular request, cost us about less than 1 cent to complete with this particular model. And it took us 7.1 seconds to complete. If you click here, we can see the actual data that we're sending and receiving from the model. Here's the prompt. We're going to see what the prompt does in a few minutes. Here's the data we got from GitHub. You see it goes on for a while because that's the raw data, like all the text. And here's the LLM response, which is much shorter. And that's what we want. We want the summary. There's a few other things that we can see too. For example, we can see the actual data we got back from GitHub. We can see the parse data that we extract out of GitHub. So that's how it looks like to the user of the application. Now let's see what's happening behind the scenes to get all that done. We're going to go through a few steps showing what's happening behind the scenes. So number one is, if we're going to summarize a GitHub issue, we have to go get the GitHub issue. So here's a typical URL for a GitHub issue, and we have to translate that into an API request to GitHub. So we translate that into this second format, which is an API request. GitHub is going to reply with a JSON payload that looks like this. So this is the issue coming back from the GitHub API. Once we have the issue, we have to go get the comments. We have a link for the comments inside the issue. When we request the comments, this is what we get back. So these are all the comments. Again, it's a JSON object with lots of information in it. We want to take that JSON format, which is pretty verbose, into something that's much smaller. So we're going to translate that JSON format into compact text format. And we do that for 3 reasons. Reason number 1 is that large objects, they cost more because they use more tokens. We just saw that the number of tokens and how much it costs us to do that summarization. If we send more tokens, it's going to cost us more. But not only cost, but in number 2, we have the second problem that if you send more data to the large language model, it takes longer to complete. So even if you're not paying for a model, if you're running a local model, sending more data to the model is going to take longer to get a response back. And number 3, which is also very important, is if you send a lot of data, it may not fit into the large language model context window. Like the context window is the working memory for the large language model. If we send more data than fits in the context window, the large language model is going to say, sorry, I cannot reply to you. So it's important that we send only what's necessary. So our job in step number 2 is take the JSON format that we see here and translate that into only what we need, which is the format that we see here. That's a compact text format of that JSON object. Now that we have that JSON format, we can now prepare the prompt. The prompt is us giving instructions to the large language model to do what we want. Here is a typical prompt. Prompts vary by what you want to do. In this case, we want to summarize. So here's the prompt that we're using. A few things that you can see in this prompt are typical prompt techniques. At the very top, we are kind of giving the context to the model. Like you should be prepared to see a GitHub issue, and you're going to see a parsed GitHub issue. And now we start telling the model what we want. We want the model to extract this piece of information. So, for example, the summary of the issue. We want the comments also in a summarized format. And we want the model to do that in a specific format. We want the model to be concise. So the model doesn't know that, so we have to tell the model that's also part of the prompt. And here's us telling the model that we want the model to be concise. Like, don't waste words, use short and clear, complete sentences. And finally, we tell the model in which format we want the answer. We want the answer in Markdown. Just because it's easier for us in this case, you can request in different formats for different reasons. But the important things of the prompt are to be precise, tell the model what the model is going to get. So you're getting a GitHub issue, tell precisely what you want. I want this, and tell the model how to do it. I want you to do in this format. Once we have all that, we can finally send it to the large language model. Most of the large language models, they have a REST API to interact with them. And those REST APIs, they vary from model to model, but they generally follow the format that we see here. In this case, it's the OpenAI REST API, and in their API, they separate the prompt into 2, like the system prompt, which is what we just saw, and then the user prompt, which is what the user has typed. In this case, data that we fetched from GitHub. We also set the temperature. Temperature in large language models means how creative we want the model to be. And in this case, we don't want the model to be creative. We want the model to be precise and reproducible. So we set the temperature to 0. The model is going to reply to us, and we can finally then show the response to the user. The response looks like this. The actual response has been removed. It would be right here. The summary would be right here. But you can see that we get the response back, and we get a few other things like reason for stopping. We also get how the data that we use for the tokens. We can see here that the model tells us how many tokens were used for completion, meaning to the answer from the model, how many tokens that we sent, like the prompt tokens, and adding up to 2 here. So that's what's happening behind the scenes. So now we're going to see a few items on how to develop applications using a large language model. So we're going to start, we're going to cover the following things in the next sections. We're going to go over a very simple issue first in number 1, just to see how the large language model summarizes it. In number 2, we're going to try a large issue just to see what happens when it doesn't fit in the context window. In number 4, we're going to see what happens when we switch from one model to a better, like a more powerful model, what we get back from that. In number 4, we're going to see the importance of using a good prompt. And in number 5, we're going to see when not to use a large language model. So let's start with the simple issue to see what's happening behind the scenes. So in this case, we're going to repeat what we just saw in the first example, where it looks like this. That's the first issue that we have summarized. We enter the issue here, we send it to the model, we got the request back, And this is everything that was happening behind the scenes is here. So we have the prompt, we have the data that we extract from the user, and we have the response back from the model. So this is the good case. Like everything works nicely and perfectly. Now we're going to switch to a large GitHub issue. In this case, we're going to select a different issue, this one here, and we're going to see what happens. What will happen in this case is we're going to get an error back from the model. The model is going to tell us it's over my context window. It doesn't fit in my context window. And then we're going to see how we can get around that model. To make the problem happen, we're going to switch to a different issue, this one here, and we're going to say summarize it. And that's the error. The model is telling us I can only handle 4,900 tokens, and you're trying to send 4,154. It doesn't fit in my context window. There's a few ways to solve that. One is we can try to shorten the prompt. But if we shorten the prompt, then we're losing information because we want the entire information to summarize. Another way around this is to use a different model, a model that has a larger context window. This is a relatively small context window, but you can select a different model that has a larger context window. So let's switch to them, a different model. And we do that by clicking at the top and picking a different model. We're using GPT 3.5 Turbo. We're going to switch to 3.5 Turbo 16K. 16K means that the context window now has 16,000 tokens. And we know that's going to fit. So let's click here. And now with this larger model, because the context window now can fit our request, the model can process the request. So behind the scenes now the model is creating the summary for us. Well, a few things that we can see happening now is that it's going to take longer. As a rule of thumb, a larger model will take longer, partially because now we're sending more data than we used to send before. And you can see a few other things here that obviously we're sending more tokens, but the other thing that you see is that in the previous request, we didn't even spend 1 cent. And now we're spending almost 2 cents. This is another consequence of a model that has a larger context window is they're more expensive. It's not the same price per token, they charge more per token. The reason for that is because it takes more computing power to work with a larger context model. Even if you're not paying for the model directly, like in this case we are paying to OpenAI, but if you're not paying directly, you're going to pay indirectly because you need more hardware. Even if you're running locally, now you pay for more hardware to run that, the larger model. The other thing that happens is you can see it takes significantly longer, like many more seconds to generate, but we get a response back. And here's the response that we get back from the model. You can see that we did get a summary. Right? One thing that we notice is that the summary is a bit on the verbose side. We're not getting only one sentence, we're getting like large sentences back from the model. What we're going to do next is we're going to switch to a more powerful model. What the more powerful model is going to do is generate a more concise summary for us. You can see in the picture, I know we cannot read the text, but we can see in the picture at the top that the texts are larger. You can see that they go over like more words. And at the bottom here, you can see the summary from the GPT-4. You can see the texts are much more concise with GPT-4. And that's what we're going to do here. So that's exactly the same large issue that we summarized with GPT 3.5. We're going to now switch to GPT-4. And we're going to ask for a summary of that issue. So many seconds later, here's our response. It's about the same tokens, but you can see now that it's costing us almost 20 cents. So that's again 10 times more expensive than the GPT 3.5 16K, which was another 10 times more expensive than GPT 3.5. So one of the consequences of using a large model is that it costs more. And even if you're not paying directly, like in this case, you would be paying indirectly because now you need even more hardware to run such a model. We can also see that it takes a lot longer, like it took over 1 minute to get that response back. But on the other hand, we get a more concise summary. Like you can see that the summary here is sharper, the sentences are more concise, they're more to the point. Let's go back to our GPT 3.5 model in a different issue and see what are the consequences of not being very precise in the prompt. What we're going to see in this example is we're going to switch back to the simpler model. We're going to switch back to the simpler issue, the one that we used in the very beginning. And we're going to generate a summary. It's going to look like this. Then we're going to modify the prompt. We're going to remove those instructions that are telling the model to be precise, short and concise. And we're going to see the difference that it makes. So let's go back to our application. Let's switch to GPT-3.5. Let's remove the precise instructions from the prompt. Go back to our simpler issue and ask for a summary. So here's the summary. You can see that in the summary we have, it's more wordy compared to the previous one. So let's go back to the previous one for a second. Keep this one in mind, where we have suggestions of solution, providing code, thanks, helps with solution, confirm the solution worked. Let's go back to our original prompt. Let's take those words back into our prompt. And ask for the summary again. And here we can see that the summary is shorter than before. So this is the importance of having precise instructions in the summary. Creating a prompt like this goes by the general name of prompt engineering. There's many resources out there on how to learn prompt engineering. There's a few links here. Just Google for prompt engineering, you're going to find some other resources. Now let's go to a case where we should not be using a large language model. The thing that happens when we start using large language models that we realize how much they can do is that we try to do everything with them. In this case, we're going to see one scenario where we try to do something and it doesn't go very well. We're going to ask for the model to tell us how many comments are there. We're going to add this one line here, telling the model, we want you to tell me how many comments are there. And we're going to use an issue that has several comments just to see what the model can do with that instruction. So let's go back to our application. And we're going to change the prompt again to say right here and say count the number of comments. Okay. And let's request this summary. Okay, here is what we have requested. We requested a number of comments and the model gives us a number of comments and it says 6. But when we look at the comments, we can count 1, 2, 3, 4, 5, 6, 7, 8. 8 comments. Right? So the model got that wrong. And this is the typical thing that models are not necessarily good at doing because they're not computer programs. They are just generating one word after the other. So one very important thing to keep in mind when we are using large language models is that they are not executing the instructions. Like, even though the prompt looks like a set of instructions, they are not real instructions to the model. What the models are doing is they're simply generating like one word at a time, like one word after the other. Right? They have no reasoning or no knowledge of what those words are. They pick the next word based on the previous one, and that's all they can do. So when you tell the model, I want the number of comments, the model is not going through the number of comments and counting them one by one. So don't treat the model as a computer program, because it's not. There are many cases where we should not ask the model to do things for us that we can easily do ourselves. For example, in this case, we already have access to the information we want. We already know the number of comments that we got back. We got a JSON, and we can simply ask how many elements are there in that JSON dictionary. And that's it. That's all we need. Right? So don't use large language models as if they are computer programs, because they're not. We've reviewed these topics, like how to prepare data using LLM models. The thing to remember here is we want to use a compact representation of the data, to use as few tokens as possible. We want to build good prompts and that tell the model what to do. We saw how good the LLMs are, and sometimes how good they're not at summarizing data. We saw some limitations on using developing large language models applications, for example, the context size. We saw a few items of how to develop good prompts, like how to be precise in the prompts. And finally, we saw when not to use large language model. And just as a reminder, this entire project is in GitHub. You can download that and experiment with the code. And thank you for watching.